Square root of a into b into c is 504. Is b divisible by 2? Here we have a question that needs to be answered in the form of either yes or no. But before we proceed, we should simplify the question because we have that multiplication of three numbers and square root of the result is equal to 504. So we can square it both sides at first. That means a multiplied by b multiplied by c becomes square of 504. But at the same time, I'm also prime factorizing 504 and I can see that it's divisible by 4. So let me quickly divide it. And when we divide it, it becomes 1, 2, 6. That means I can say that a into b into c is equal to 2 raised to the power 3 multiplied by 63. 63 means 2 square multiplied by 7. And we have the square of it. That means we have a into b into c 2 to the power 6 times 3 to the power 4 times 7 square. The question is asking whether b is divisible by 2 or not, which means the other prime numbers are not much useful to us. All we have to find out is that these powers of 6, how are they distributed among these three numbers a, b and c. Now let's quickly look at these statements and judge the merit of the information available in them. So c is equal to 168. We need to prime factorize this as well. We can see that it's divisible by 8. So we can write it 8 multiplied by 21. That means c is equal to 2 raised to the power 3 times 3 times 7. So all that we can see is that c is contributing 3 powers out of these 6 powers. So what about the remaining 2 powers of 2? Then either a can have all the remaining 3 powers and the b may not have any power of 2. That's case number 1. But likewise, case number 2 is also possible, in which a has 1 power of 2 and b has remaining 2 powers of 2 and the other factors, which we are not much concerned about because we are only looking for the distribution of the 6 powers of 2. So since in one case b is not divisible by 2 and in other possible case b is divisible by 2, therefore we can state that the first statement is not sufficient to answer the question and rule out two options, which are A and D. Now let's look at the second statement. The second statement says that A is a perfect square. Now let's quickly understand what is a perfect square. Perfect square is defined as a number which on prime factorization results in a number in which all the prime numbers have even powers. That means since A is a perfect square, so the power of 2 in A could be either 0, the power of 2 in A could be 2, the power of 2 in A could be 4, or the power of 2 in A could be 6. In first scenario, we may have B which is divisible by 2 because C may have the rest of the power, and in the last case we will have no power of 2. So the answer to the question is once again sometimes yes and sometimes no. Inconsistent answer, which means the second statement alone as well is not sufficient to answer the question, ruling out another option, option B. Now the third step is combining the two statements. The first statement has confirmed that C consumes 3 powers of 2. That means the remaining powers of 2 to be distributed are 3, right? Now, the second statement confirms that A is a perfect square. That means A can have either 2 to the power 0 or 2 to the power 2, but now A cannot have 2 to the power 4 because we are left with only 3 powers of 2 at this stage. So case 1, when A takes 0 power of 2. In that case, we will have to assume 3 powers of 2. That means B is even, giving the answer to the question as yes. The second case is when A has 2 powers of 2. In that case, since 5 powers have been taken care of, so there is 1 power left to be given to B. Even in this case, the answer to the question is yes, and there is no other possible case that exists. Since we are getting unique answer to the question, therefore the two statements together should be sufficient to answer the question, and the answer becomes option C. So the key to answer this question is the prime factorization of the number and looking at how the distribution of one prime factor is happening among different variables. I hope that helps. Thank you so much for watching this video.